Okay, stats, let's keep going. We were talking about using the z-table to find areas. We've done a few problems. Let's do one more. A bank's loan officer rates applicants for credit. The ratings are normally distributed with a mean of 200 and a standard deviation of 50. If an applicant is randomly selected, find the probability of a rating that is between 170 and 200. So this is two different scores if it's between, so I need to find two different z-scores. So 220 minus 200 over 50 equals 20 over 50, or 0.4. We also need the z-score for 170 minus 200 over 50, which is negative 30 over 50, which is negative 0.6. Remember, for the area between, we take the bigger one, the 0.6, minus the smaller one, using the table. If we use the table, we find the area to the left of 0.4 is 0.6554. The area to the left of negative 0.6 is negative 0.2743, and we subtract them. So the chances of finding someone between those two, if a person's picked at random, is 0.3811. Now, all of these, we took values, turned them into z-scores, and got an area. But what if you want to go backwards? What if you want to take an area and go back to the actual score? Well, let's try this. Find the z-value such that the area to the left is 0.8212. So we find 0.8212 in there, and we break it down into its components. Looks like 0.9 and 0.02, which means that's the number 0.92 is the z-score. That gives you the area to the left of 0.8212. So you start at the score and go backwards. Now what happens if it asks you to find the area to the right? We know that the z-table only tells us the area to the left. So I need to take 1 minus that 0.2015 to get the area to the left, which is 0.7985. So I'm looking for 0.7985 in here. Now when I look for 0.7985, I notice there's a 0.7967 and a 0.7995. There's not a 0.7985, but 85 is closer to 95 than 67, so I should use the 0.7995, which looks like it's 0.84 as a z-score, or 0.84. So we can go backwards if necessary. So now, if we can find a z-score, we can then use our algebra to get back to like an actual x value. So we draw a normal curve, shared the area, use the table to get the z-score, and then undo our z-score formula to get x. Now remember, the z-score formula was x minus mu over the standard deviation. If I solve this equation for x, I need to multiply the standard deviation to the other side and add mu. You can either use this or go straight to that formula for x. Either one works. The combined verbal and quantitative reasoning score on the GRE is normally distributed with mean 1049 and standard deviation 189. What is the score of a student who ranked in the 85th percentile? Okay, so what does that mean? 85th percentile means that 0.85 is to the left of the number. So what does that mean? And we need to look at the table for finding the thing closest to 0.85. The closest one, if we look, is 1.04. So that's my z-score. So I need to take that and go back to x. So x equals mu plus z times sigma. Mu is our average, which it says is 1049, the mean, plus 1.04, our z-score, times sigma, our 189, our standard deviation. And this ends up being, if you put it in your calculator, 1245.56. Now you can't really get that on a test. You might round to the next number up. So roughly 1246 as a score. So this is how we would go back. So the score on the GRE that's in the 85th percentile is a 1246. Okay, another word problem. It is known that the length of a certain steel rod is normally distributed with a mean of 100 centimeters and a standard deviation of 0.45 centimeters. So suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make up the middle 90% of all steel rods. Okay, so we want the middle 90%. If it's the middle 90%, that means 10% aren't taken, but it's split on both sides. So that means there's 5% here and 5% here. So what does that mean about my z-score here? It means how much of it is to the left? 90% plus another 5%. So I'm really looking for a 0.95 to the left here. For this one, the only thing to the left is 0.05. So the two scores that I need to find are a 0.95 and a 0.05. Now, they're symmetric. Because the normal curve is symmetric, it should be the positive and the negative of the same thing. So if I look for where 0.95 is, I find that it's around, it looks like it's halfway between 1.64 and 1.65. So I'm just going to put 1.645, and this one is the opposite, negative 1.645. So what I need to do to find these two scores is say x equals, again, mu plus z times sigma. And this one is x equals mu plus z times sigma. The only difference is it's going to be a negative z. So x is 100 plus 1.645 times 0.45. And here it's 100 plus negative 1.645 times 0.45. What do we get? This is 100.74 centimeters, and this one is 99.26. So what does that mean? He should accept rod lengths between 99.26 and 100.74 centimeters. Okay, so that's all the types of problems, but there's one little caveat. There's something they will mention in the problems that you should be aware of. You may see a z with a little sub number. We call that z alpha, and what it does is it measures the area to the right. So when you see z and then a little subscript of 0.1, that means 0.1 or 10% is to the right of a number, and the other 90% is to the left. So find the value of z of 0.1. That means 0.1 is to the right, which means 0.9 is to the left. So on the z table, we really are looking for 0.9, not 0.1. So just be careful of that. And that occurs around the z-score of 1.28. So when it says find the value of z of 0.025, again, on the curve, that means 0.025 is to the right, and 1 minus 0.025 is to the left, which is 0.975. So we're really looking for what? 0.975 on our table. And the one that gives us that is 1.96. So the value of z of 0.025 is 1.96. And that is all for 7.2, which is the last section in Chapter 7. And we'll do more next time.